Everyone, and welcome. Today, we are diving into something really cool. Some new research from MIT that could totally change how we build AI. We're talking about making it smarter, faster, and way more efficient, all at the same time.
So let me just start with this question. What if an AI model, instead of just getting bigger and more bloated, could actually get leaner and more efficient while it was learning? I know, it sounds a little backward, right? But that's the wild idea behind this brand new technique.
Now, to really get why this is such a big deal, we need to talk about this fundamental problem that pretty much every AI developer faces today. It's a really, really expensive trade-off.
And this slide, wow, it lays it all out perfectly. For the longest time, you had this stark choice. You could train a giant, massive model to get that top-tier performance, but it would cost you a fortune. Or you could train a small model to save money and time, but you had to accept that it just wasn't going to be as good. It was always power or efficiency. You couldn't have both.
And you know, when we say cost, we're not just talking about millions of dollars. We're talking about an insane amount of time, a massive energy bill. I mean, the sheer computational horsepower you need is staggering. It's a huge barrier that really limits who can even try to build this cutting-edge AI.
But what if we could just sidestep that whole trade-off? Well, researchers at MIT and a few other top universities have come up with a much, much smarter way to train these things.
It's called CompreSSM, and what it does is flip the whole script. Instead of training a model and then trying to shrink it down afterward, it compresses the model during the training process itself. Think of it like this. Instead of building a 100-story skyscraper and then trying to knock out 20 floors to save money, you're building a smarter 80-story building right from the start. The lead author on the paper, Makram Shaheen, he put it perfectly. The model doesn't just learn, it learns what's not important and gets rid of all that junk, that dead weight as it goes. It's kind of like a sculptor who's chipping away all the extra stone to find the statue inside, except they're doing it while the stone is still forming. It's brilliant.
Okay, so let's get into how they pull this off, because it is incredibly clever. It all boils down to this key insight they figured out, and it happens really early in the training process.
So they use this mathematical tool from a field called control theory. It's called Hankel singular values. Now, don't worry about the name or the complex math behind it. The easiest way to think of it is like a high-tech scanner. This scanner peeks inside the AI model and basically creates a ranked list of which parts are the heavy lifters, the MVPs, and which parts are just, taking up space.
And this right here shows the whole process. They kick off the training, but only for the first 10% or so, just a little warm-up. And during that warm-up, they fire up that Hankel value scanner to find the most critical parts. Then, and this is the key, they just surgically remove the dead weight, all the stuff that isn't pulling its weight. Then, the model finishes the rest of its training, the other 90%, but now it's way smaller, leaner, and a whole lot faster. Okay, so that all sounds great in theory, right? But does it actually work? Let's get to the results, because this is where it gets seriously impressive. So, on a standard test for image classification, the CompreSSM model hit almost 86% accuracy. But here's the kicker. A different model that was just trained to be that small from the very beginning, it only got about 82% accuracy. So with CompreSSM, you get the efficiency of a small model, but the high-end performance of a much bigger one. It's the best of both worlds.
And it gets even better. When they used this on Mamba, which is a really popular and important AI architecture, they saw a training speedup of about 4 times. That's not a small improvement, that is a massive, massive gain.
Daniela Russ, who's the director of MIT's AI lab, she really just nailed why this is such a big deal. It's about making compression and efficiency a core part of learning, not some cleanup job you do at the end if you have time.
So you might be wondering, how does this stack up against the old ways of doing things? Well, let's do a little head-to-head comparison because it really shows you why this is such a powerful new approach.
This table just says it all, doesn't it? The old methods, like pruning, make you pay the full price to train a giant model before you can start shrinking it. Another technique, knowledge distillation, basically makes you do the work twice. CompreSSM is just smarter. By compressing in the middle of the process, it avoids all that wasted time and money right from the get-go.
And check this out. It's not just beating the old school methods. They put it head-to-head with another recent, pretty advanced technique, and CompreSSM was more than 40 times faster, and it was still more accurate. I mean, that's not just a win, that's a total knockout. So what does this all mean for the future of AI? Well, it feels like we could be heading into a whole new era, an era of lean AI.
And the experts are definitely taking notice. Here's a quote from Antonio Orvieto, an expert who wasn't even involved in the study.
He says this work is opening up brand new doors for research, and that it could become a standard way to train a whole class of really important AI models.
And the team isn't stopping here, not by a long shot. They're already figuring out how to apply this to even more complex AI systems, and getting it closer and closer to the giant transformer models that power things like ChatGPT. This really is just the beginning.
Which leaves us with one final thought to chew on. For years, the race in AI has all been about who can build the biggest, most massive model. But maybe, just maybe, this research is showing us that the smartest way forward isn't just about getting bigger. It's about getting leaner, more efficient, and ultimately more accessible for everyone.